All right, everybody. Welcome to Mr. Diego Tutoring on Instagram and Crushing Chemistry on YouTube. And today I am going to show you how to never get stoichiometry wrong again with a technique called math with the units and a very, very direct way to interpret the question. So let's begin. Bear with me and you'll never get stoichiometry wrong again. The question says 6 moles of copper, Cu, are mixed with 12 moles of dilute nitric acid. So we got our two reactants here. I color coded them. The equation for the reaction that occurs is shown below. And then you got the equation here. It's already balanced. What is the amount in moles of nitrogen 2 oxide, NO, produced assuming that the reaction goes to completion? First things first, it is giving us 2 reactants and it wants to know the amount in moles of our desired product that I highlighted POI, product of interest, over here. So what are we going to do? We need to test out these 2 reactants. So always start with what you have. You have, as the question clearly stated here, 12 mole of HNO3. Now, here's your thought process. Do you want your answer to be in moles of HNO3? No. So you're going to start a fraction here and you're going to put what you don't want on the opposite side. In this case, in the denominator. If the question wanted mass, we would need the molar mass of the reactants and the product. But the question wants the moles. So for that, you are going to use the coefficients of the equation. So what is it that we want? We want moles of NO, of nitrogen oxide. When you're doing a mole to mole conversion, all you have to do is, assuming your equation is correctly balanced, you use the coefficients. So what is the coefficient of NO? 2. What is the coefficient of HNO3? 8. Look at what's going to happen to your units. Moles of HNO3 cross out with moles of HNO3. Our resulting unit is moles of NO, which is exactly what the question is asking of us. So now you just put the equal sign, repeat the unit because you're sure that that's the unit that's going to come out. And now all you have to worry is about the math. 12 times 2 divided by 8. And that's going to give me 3 moles of nitrogen oxide. On to the next one. So we need to see if that's the actual value. We're going to do the same thing. We start with 6 moles of copper. Start with what you have. 6 mole of copper times. I don't want my answer in moles of copper. I'm going to put moles of copper in the denominator. What am I going to put in the numerator? What I want. Moles of NO. And from here, you just repeat the coefficients like we did last time. The coefficient of NO is 2. The coefficient of Cu in the equation is 3. Now, all you have to worry about is the math. So you know that moles of copper and moles of copper cancel out, and you're left with the unit mole of NO. Now just worry about the numbers. 6 times 2 divided by 3, and that gives me 4 moles of NO. So which one is the right answer? Well, the limiting reactant, which implies the actual value that is going to be produced, is always the lowest value when you're comparing 2 reactants and a product of interest. So if our stoichiometry with copper yielded 4 mole of our product of interest, and our stoichiometry with nitric acid yielded 3 mole, this is the lowest value. Therefore, this is the correct value, alternative A. You can safely infer that HNO3, because that's the lowest value, it's your limiting reactant, and copper is your excess reactant. And that's always going to work. You are never going to get stoichiometry wrong again. See you next time that we crush some IB chemistry questions. Have a good one, everybody. See ya.